Hey guys, this is the first video of solutions for pre-AP chemistry, so let's get started. So first we need to talk about what a solution is. A solution is also known as a homogeneous mixture, which if you remember from way back in the beginning, a homogeneous mixture means that it all pretty much looks the same. So if we take salt and we put it into some water, then you wouldn't be able to tell the difference between the salt and the water. It's not like oil and vinegar or oil and water where it doesn't mix together. It dissolves into it. All right, and so to define some of these terms that we're going to be using a lot in this unit, the stuff that dissolves is called the solute. So the salt here would be the solute and the water would be the solvent. So the solute is what dissolves inside of the solvent. All right, and another definition that we have to define is concentration. So concentration is usually given as the amount of solute dissolved in a certain given amount of solution. And we've seen these everywhere in our day-to-day lives on things like hydrogen peroxide, alcohol. You've seen 70% isopropyl alcohol in the alcohol bottles in the grocery store. You've seen it's 3.5% hydrogen peroxide that we use to clean wounds. So it's everywhere. But what we use in chemistry usually is something called molarity. And molarity can be defined as the moles of the solute dissolved in liters of the solution. Now that right there is just an abbreviation for solution. It's very commonly used. All right, so to find the molarity of a solution, we would just take the moles of the solute and divide it by liters of the solution. The abbreviation for that would be the capital letter M, and that means molarity. So if we have a 0.5 molar solution of, let's say HCl, then we say 0.5 molar solution of HCl. That's what the big M stands for. This also, if it says what's the concentration, it's asking for molarity. So anytime it says what's the concentration, it's asking for molarity in chemistry class, unless it otherwise specifies that you need to use a different concentration. All right, so here's some examples so that you know how to work your problems. It first says, what's the concentration of a solution that has 5 moles of solute dissolved in 2 liters of total solution? So since it says concentration, we know we want to find the molarity. And the molarity is going to be the moles of the solute divided by liters of the solution. So I'm just going to plug that in. And plug that into my calculator. So 5 divided by 2 would be 2.5 molar. All right, and the next question says, what is the molarity of a solution that has 5 grams of NaNO3 dissolved in 250 milliliters of total solution? So for molarity, I know I have to find the moles and divide it by the liters, and I've got grams of sodium nitrate and 250 milliliters of solution. So that means that I'm going to have to find the moles of this, and I'm going to have to turn this into liters. So to get started, I'm going to do the moles first. And the molar mass of sodium nitrate is found to be 85 grams. So that's the molar mass. And that gives me 0.058824. And then I have 0.25 liters. Or if you guys don't remember, there's 1,000 milliliters in a liter. So if I have 250 milliliters, there's 1,000 milliliters in 1 liter. And so that would be 0.25 liters. So now I'm going to take the moles of the solute, that's the stuff that's dissolved, and divide it by the liters of the solution. So 0.058824 moles of sodium nitrate is dissolved in 0.25 liters of solution. So that gives us 0.235 molar, or moles per liter. All right, a couple more. How many moles of solute are dissolved in 400 milliliters of a 0.25 molar solution? Okay, so you could use the molarity equation. It's not really an equation, but you can use a molarity definition to solve if you want to. But what I suggest you do, because it will make your life easier later, is anytime you see that big M molarity, change it to moles per liter. All right, and when we do the problems like this, where you're looking for moles or you're looking for liters of the solution, you're always going to start with the number that does not have a denominator in the units. So start with the number that does not have units in the denominator. So molarity is moles per liter, and then we have milliliters. This does not have, milliliters does not have any units in the denominator, so we're going to start with that number. So I'm going to start with 400 milliliters, and there are 1,000 milliliters in 1 liter. Now, since this 0.25 moles per liter, it can be used, since it has units in the denominator, it can be used to go back and forth between moles and liters in the same way that molar mass can go back and forth between grams and moles. So molarity can be used to go back and forth between moles and liters. So which part has to go on the bottom? The liters would have to go on the bottom so that we cancel out liters on the top here. So what this says is we have 0.25 moles for every single 1 liter per liter. So I'm going to put 0.25 moles per liter. And then if I put that in my calculator, 400 divided by 1,000 times 0.25 moles, I end up getting 0.1 moles. All right, next we've got how many grams of HCl are dissolved in 0.235 liters of a 1 molar solution. So again, I'm going to cross out the molarity and put moles per liter. So that helps me know that I can go between units of moles and liters with that. And then I have 2.35 liters. And I'm looking for grams. So the only way to get to grams is to come from moles. So first I need to find moles. And I'm going to start with 2.35 liters because there are no units in the denominator here, whereas we have liters in the denominator on molarity. Okay, and then my solution has 1 mole per liter, and that would give me 2.35 moles of HCl, but I want grams, so I'm going to use the molar mass of HCl, which was found to be 36.46 grams per mole, and then 2.35 moles times 36.46 grams per mole is 85.7 grams, or 86 grams of HCl. All right, last two problems. So this time I'm looking for milliliters of solution, and I've got molarity here, so that's moles over liter, and I've got 2 moles of solute. So which do I start with? Do I start with 2 moles of solute, or do I start with 0.55 moles per every single liter? I'm going to start with this one because it doesn't have any units in the denominator. So we'll start with moles. And remember, this means that there's 0.55 moles in 1 liter. So 0.55 moles is equal to 1 liter of solution. So I'm going to have to put the 0.55 moles in the bottom so that I cancel out moles up here on the top, and that's for 1 liter of solution. So I'm going to take 2 and divide by 0.55, and I end up getting 3.6 liters. Now I want milliliters, so then I'll convert it to milliliters. 1 liter is 1,000 milliliters, and so that is going to be 3,600 milliliters. All right, how many liters of solution will be required for a 1.25 molar potassium sulfate solution containing 3.5 grams of solute? All right, so I've got 3.5 grams of solute and 1.25 molar K2SO4 solution. So what that means is that my solute is K2SO4, and there are 1.25 moles of that dissolved per liter. And I've got 3.5 grams of it. So I'm going to start with grams because it doesn't have a unit in the denominator. And I need to convert it to moles. And the molar mass for potassium sulfate is 174.27 grams. And I know that I have 1.25 moles of potassium sulfate dissolved per liter, so for every 1 liter. And I had to put moles on the bottom here to cancel out with moles on the top. So then if I put that in my calculator, 3.5 divided by 174.27 divided by 1.25, I end up with 0.0161 liters. All right, and that's it. So if you have any questions, please feel free to email me, and good luck.